Alright, so this is the Calculator OK review. And so you guys, hopefully you're reviewing your parent graphs, that yellow sheet. You'll have to know all it, because, on the final minute, I probably will ask something other than an absolute value. It might be one of the other ones on there, but I'll ask you to do the same things with it. Okay? And then we talked a little bit about the 3 restrictions that we've talked about this year. So underneath the square root sign has to be greater than or equal to 0. If you have a rational function, you set the bottom not equal to 0. In a logarithmic function, you're going to set whatever you're taking log of strictly greater than 0. So those are the 3 restrictions you could be asked about. You guys remembered your polynomial stuff here? The quadratic formula you'll need to know. Working backwards, I give you the zeros, you build the polynomial. Okay. And then I think we had a lot of you guys had discussed horizontal asymptotes with you. Seems like we remember vertical asymptotes are whatever factors are on the bottom that don't get canceled out, right? Set them equal to 0. Horizontal asymptotes, there are 3 cases. Either the power on top is bigger than the power on the bottom. You could have something like x cubed over x squared. There's no horizontal asymptote for that. If you have x squared over x cubed, so the degree on the top is smaller than the degree on the bottom, y equals 0 is the horizontal asymptote. And then you have something like in this case where they're the same top and bottom. So 2x squared over x squared, y equals 2 is your horizontal asymptote. Okay, so these are the 3 different cases for horizontal asymptotes. And it seemed like we were okay on vertical asymptotes. Then number 6, we factored the top on 6 and canceled out the x minus 2's. And that's called a removable discontinuity. And so if you set x minus 2 equal to 0, you get x equals 2 is the x-coordinate of the whole. And to find the y-coordinate of the whole, you just have to plug 2 into what's left over here, which is x over x plus 3 times x minus 3. If you plug 2 in here, you'll get 2 over 2 plus 3, 2 minus 3, which is negative 2/5. And so I was pretty specific on number 6 that you had to know what the y-coordinate was to be able to tell which one of which one of these it could be between D and A. It had to be A because the y-coordinate was negative 2/5, not positive 2/5. That was 1 through 6. So you had a question on 7. All right, I want to run through 7. Oops, no, that's not what I want. All right, so number 7, let's run through this. It says, use the graph to answer the questions. Is the degree even or odd? Well, the parent graph for this would be a cubic that goes like this, and it has arrows here and here. Notice the arrows here and here. What has happened to the parent graph? Flip. What flips the parent graph? That was actually B here. What flips the parent graph? Negative. So here on B, it's the leading coefficient has to be negative. Is the degree even or odd? We can answer that based on the parent graph as well. Does this fit with a parent graph of an odd cubic or of an even squared? Odd. How do you know? Just know these things. Yes, the cubic goes the opposite direction. The quadratic, they go the same direction. So a quadratic would be something like that. They're going to go the same direction in the end. So here we know the degree must be odd. What is the smallest possible degree? Well, how do you figure out the smallest possible degree here? You guys remember? What do you do to figure out the smallest possible degree?
Count all the bumps.
Okay, count the bumps. So I have, that's right, I have 1, very technical language, 2, 3, 4, and then what do you do with those?
Subtract one.
No, add one.
You add one.
Add 1 to it. So 4 plus 1 is 5. Good. What are all the real zeros of the function? Well, how do you get zeros of the function here from the picture? What's that? Where it crosses the x-axis. So here, 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 and here. How many is that? 1, 2, 3, 4, 5 of them. So what are the real zeros? Can you label them? Did you already label them? So -4. What else? And 3, okay. And then is the multiplicity of each zero even or odd? How do you tell for that? What do you do? If it crosses through, then it's what? Odd. If it bounces off of it, which none of these do, then it would be even. So these are all odd. All right. Some of the chapter 5 stuff on here we had talked about before. Any questions on the chapter 5 stuff? So the exponential logarithmic stuff? I think I had lots of individual discussion on that. I think we move on. You guys move on to chapter 6. We're not. I changed the order, so there's no linear algebra. So. What else? What are your other questions? What's the next one?
On the calculator, OK one.
Calculator, OK, 6 and 7. Okay.
Do we